can you go to the RSM code?
Yep.
I want to test on my computer first.
Here it is.
Yeah. So I just need to use GTF.
Oh, you need control. Sorry.
Oh, it's okay. GTF.
Okay. I have control if you need it.
Okay, let me just a second. SMN.
This is exactly like science. An experiment should work the first time perfectly, but there's always an error. There's always something goes wrong. You need to go back and try again and go back and try again.
Yeah. 5 is absent. Let me see. SMN. Oh, and also there's another small issue actually. When we is processed, okay. Yeah, the GTF file I sent you was it is good, and I think it was just because of the Excel saving additional spaces. Yeah, I'm trying to think about like what I did for the trying to find my previous script for doing this.
Well, we can revisit this next week, and we can do the gene expression analysis of the samples that ran against the mouse genome.
Yeah. I will send you the script or instructions later for fixing this issue.
Perfect.
So now can you just open the file, the output file that already generated? So this
Yep.
is based on no SMN2, right?
Yes, exactly. No SMN2. So we
Yeah.
have all the samples except for the 32.
Yeah. So those folders are not useful. You can delete them.
Oh, what do they contain? What is this?
It's just a temporary file that are same generate, but you want to keep the one still running. You shouldn't delete the ones that already is still running.
Okay, sorry, I tried to
Yeah,
select
you
a bit.
can. Yeah, you can delete these ones. The 24 should be fine. Yeah, and you are running, or you are, but you can delete everything because your 32 is not running.
No,
Right?
it's
Yeah.
not running. 30, 31, 32.
Yeah. So now you can open the gene results.
Should I just double click?
You can use Excel to open it, I guess. It may be easier to see
Okay.
because it is also.
Recovery failed. Okay, here we go.
Yeah.
Character, language, comma, space, other.
Yeah, it looks good. You can just click the
Okay.
no. It seems to be no comma. Can you uncheck the comma and semicolon? Yeah, it should be. Yeah, can you just click OK and we will see.
Yeah.
Yeah, you probably cannot see from here. You can open it. It's okay.
Here we go.
Okay, so now you have the some information. So the first column is the gene ID,
Yes.
We are using the ensemble. Let me, can
Remove it.
oh yeah, okay. Yeah, I can see my mouse now. Oh, so this is one, the first one is gene ID. The second one is the transcript ID belong to this gene.
Yeah.
So the first gene only has one transcript, and the length is like a 3,000 base for this gene.
Yes.
Yeah, and the effective length, I forget what that means. Effective length. Yeah, I need to check again the manual. But the useful information is the TPM and the FPKM values. So these two values are people use it to quantify gene expression levels. So TPM means a estimate of the transcript per million. The T transcript and P is per, and the M means a million. And then FPKM is the fragment per kilobase per million. So FPKM means that it estimates the quantification for this gene based on it also consider the length, the effective, use the effective length, because some of the genes, they may be longer, and then if it is longer, then when we fragment it and then do RNA-seq, the longer gene will get more fragments. So yeah, so FPKM, I think both of them are the same. So they will normalize the number of reads you get to the length, the effective length of the gene.
And
So
what criteria do you use? Do you choose the FPKM or the TPM?
yeah, so I usually use TPM because the original author who invented FPKM later published a paper showing that TPM is a little bit better than FPKM. But either the difference is super tiny. So I think nowadays the paper you can still see a lot of them people use FPKM. Yeah, there's nothing really wrong using either TPM or FPKM. Either one will work. Like for example, let me show you a website. Can I open the browser?
Yeah, if you can't see it, I can just write.
Okay, so there's a very famous website called GTEx. So this GTEx website, they did a lot of RNA-seq for like a health from the tissues from healthy donors. Like for example, SMN2. You can type the gene here, and it will show you the expression level of SMN2 across a lot of different type of tissues. Like this is brain,
Wow.
yeah, and the liver, lung, like all kinds. This is human patients, human individual samples.
Yeah.
And then so you can see here is you use TPM, right? So you can see the 5 is kind of low. Like SMN2 expression level is fairly low, and here you can actually let me see. Yeah, so this is just
muscle.
yeah. And then the highest expression happened in the brain. I think in the brain. Cerebellar hemisphere is relatively high, but it's not very high. TPM4 is not high. So from the Excel file you see, you can actually kind of feel how big the number is.
I'm interested to see because this gene is most important in motor neurons. So any like nerve cells are going to be the ones that are most dependent on its expression. But it seems like a lot of things that have to do with the brain. Oh yeah, you see here it says nerve.
Yeah,
Maybe
yeah,
to do there, but the expression in the brain is pretty much the same level.
yeah. The difference is very small. I think I remember there was a option for you to no, so there is no such. I remember there was an option for you to change the TPM to log scale.
Mm.
So there's no this one. So maybe we can try the other gene, maybe higher expression.
SMN1.
SM, yeah, SM1 should be higher, right? So it is it's kind of a little bit higher than SMN2, because SMN2 is like a below 5, mostly below 5, but here is like sometimes it's higher. Like for example, here this is yeah cervix. This is the ovary. Yeah, so it's
I'm intrigued to why it has to do with the kind of the reproductive system.
yeah. So I don't know. So but this is a good website. You can kind of have a sense how this TPM value look like. So from your Excel file, you probably will see a lot of genes has a TPM greater than 5 or 10.
Mm-hmm.
So now, oh, maybe we can try this is human. We can try like a housekeeping gene,
Yeah.
HPR1.
Yeah, 100.
Is higher, or gap. I think gap DH is even higher.
Wow.
Yeah, gap DH is a lot higher. It's like thousands TPM. So this TPM means that from a million reads, you get roughly how many reads across how many coverage across the transcript. So if you get like 2000 TPM, roughly it means that you from 1 million reads, you can get about 2000 fold coverage across the transcript. Yeah, so it's like
When I do the analysis, I'll be using these TPM values as a reference of expression levels.
yeah. So I think it's good to use TPM. Yeah, so it's kind of more popular now. How do I go to the Excel file?
Is it still there?
Yeah, can you go to Excel file?
I don't see it.
It disappeared.
Let me open it up again.
Oh, maybe I close it.
I'm not sure. No, not a problem. Oh no. Yeah, cancel. Wrong place. Open with Excel.
Yeah.
So it's ready, but it's not. Oh, this?
Oh,
It became
super
tiny.
small.
Yeah.
Yeah, so this column is TPM column is the only column you are going to use, and
Okay.
yeah, and the expected count means that how many reads you expect to get given this TPM value.
So these values are very low because all the expected values are very high and the TPMs are much lower.
No, so this is the expected read count. So this is not normalized to the total amount of reads. So this 47 is already normalized to the total amount of reads. So each sample you have like a 20 million something, right?
Mm-hmm.
I think you have like 50 million or I forget how many reads you get.
Yeah, it was quite deep in terms of sequencing, but I don't remember.
Yeah, so this is already normalized. This is the raw number of recount you get from the
Entire genome, entire sequencing.
from the whole sequencing run. Yeah.
Okay.
Yeah. So it's like so you only need this column, and then for each file, each sample you have one this genes result file, right?
Yeah.
So while you
Right.
have, huh?
Sorry, I'm trying to think the samples. Try opening the sample 20, 30, 30, because that's the treatment with the two drugs at the same time. That should be the one where we see the most effect.
Yeah, but it's hard to visually compare. But unless you have a gene of interest, you know which gene should go up, then you can actually easily check.
Sorry, here.
Yeah, it is 25. The one I open is not here.
It's ready. Says it's ready. I don't see it.
Yeah, I don't see it too. Yeah, it's okay. So to do this,
Here we go. It's tiny again.
yeah, somehow the Windows is kind of messed up.
Yeah. Here. And now we have this is 25 and this is
Yeah, like for example, the first gene TPM already go up compared to the 25 sample,
yeah.
right? So you can just
One.
yeah, if you have your like interested genes, you can just compare the TPM values. They are directly comparable. If it is higher, then it means this gene is going up.
So here, okay, and it is pretty much the data that I will be using for the analysis. I look at the gene, I look at the TPM count, and I compare it between one treatment and another.
Yeah, yeah. So this is the TPM is the gene expression level.
Perfect.
Yeah. So when you like make a bar chart showing the gene expression level, you simply use these TPM values for each sample.
Perfect.
Yeah,
And
yeah. And
one of the drugs that is in this treatment is pleiotropic. So I imagine it's going to have effect on everything. It's a histone deacetylase inhibitor that opens up chromatin and it should increase expression of most genes. So it's
yeah.
that I see there's an increase in expression.
Yeah, but I also want to show you how to do this like automatically, because
Okay.
yeah, right now it's like it's hard to do it automatically because you have a lot of genes, a lot of samples, right?
Yeah.
So there are two ways. I think there's one way. Maybe you can consider this as a like a small assignment. You can try the where is it? There is a
Also interested to, is there a way to change the gene ID to the name of the gene?
yeah. That's what you need to figure out as well. So I'm so there are two ways. One is that the RSM is using a software called EBseq, and this EBseq can take the input file of the RSM and then do the differential expression analysis. And yeah, and then I usually don't use it because I haven't tried, so I don't know. Maybe you can try. And let me find this.
Oh, I'm very excited here. I'm very happy to see numbers that I can
Yeah,
use.
I think from the numbers you already can kind of tell which gene go up, which gene go down, but you still don't have the gene name, so it's
Yeah.
very difficult to do that. Let me. Well, I opened the page before, but somehow disappear. Let's see. Yeah, I will send you a link from the chat. So that is the like the instructions for running the EBSeq for RSAM's output. And then the other, to me, the other way, maybe easier for me to do is just use my own script. I can send you the script and you can give it a try.
Okay.
So yeah, so let me see. Okay. Okay, so I will send from the chat. Where is can you open the browser? I want to show you the link. Maybe it's better to just put it here.
EBSeq, was it?
Yeah, it's EBSeq, but from here this is RSAM, right? And
Yeah.
at the bottom there's a section for differential expression analysis. Let me see. There are many ways to do this differential expression analysis. So like here, this section shows the EBSeq. Yeah, so you can kind of follow the instruction here and then try to use the EBSeq to generate some differential gene analysis.
Yeah.
Yeah, so this is one way. The other way is that I have a script that you can run. I think it should be easier to do. But I will recommend that you can try this EBSeq first, and then we can. It's kind of like a practice for you to get more familiar with the other softwares and then how they incorporate each other's function together. This is I think it's a good practice. I don't know if it works because I never tried the EBSeq. But I think I'm going to send you the script. We can just try now. Let me see. Do you still have like 10 minutes?
Yeah.
Okay, that's good. Let's see. Did you get it? It's from sent to your email.
Email. There we go. Or
Yeah.
send.
Then, but the first thing we need to install a few packages. Let me see.
Okay, should I extract this?
You found it?
Yeah, RSM.
Yeah, so I'll recommend you can put this script under the, let's say not under document or no, under the, you can create a folder here, like where is the creator?
Wait, I think it's selected the hello CC.
Yeah, I want to create a folder here so you can put the script here, so it will be easy for you to run it.
this folder. Yeah, new folder.
Yeah. Like you can type a Perl, something like Perl. Let me see. PER. Perl. And then the download here, right?
Mhm.
Move to. Okay, good. So now we just need to, we have to install some program first. We need to install.
Sorry, if I do CD, oh, go back here, and from here, ls.
Yeah.
Then I have CD Perl. Just checking that I can do these things.
Yeah.
Very
Good.
good to know.
So the first command we have to install is the Perl. I think your computer should have Perl.
Yeah, I do have Perl. If you check the version, it should tell you.
Yeah.
Yeah.
Yeah. But we need to install a few libraries.
Okay.
Does your computer has R?
I think I installed it.
Oh,
Yeah.
good. That's nice. So I think we don't have to do that. Okay, then the other is.
We have 10 minutes now.
Okay.
Yeah, I was running again.
Yeah, so Perl. So you will show you what you are still missing. Yeah, this is CPAN is a software for installing the Perl modules.
Okay.
Yeah. Okay, and we need to install PDL. PDL, I think it's PDL Lite. Oh, Lite F.
So with this program, what is it going to make me do?
Yeah, you will simply do the you will took the average of TPM values, and also you will generate the fault change value and generate the p values comparing like by comparing two groups of samples.
Fantastic.
Yeah,
And
so it will be easier to analyze.
will it help with the gene name as well?
Yes. So we just need to give it the file that has the gene name, the GTF files. So it will do everything, I think.
That's how I like it.
Yeah, so I will kind of recommend you to try the EBSig as well. So I think there are just many ways to do downstream analysis, and yeah, so you can try other approaches.
Mm-hmm.
Yeah.
And this PSeq and Perl arrive at the same conclusion.
The conclusion should be the same. The difference may be small, I guess, but the DBSeq may give you some plots. You can kind of it will help you generate some plots.
Okay.
Like I think from the website it shows some like a similar like a scatter plot, and I don't know what else you can generate. So using that kind of package, the advantage is that you can generate some pretty like a good looking plots and maybe easier, but the maybe hard to run sometimes because you have to figure out all the parameters you have to specify. Yeah, so it's yeah, it's oh, this is taking longer than I expected. It's kind of slow.
It still looks like magic to me, like I'm in the Matrix when I look at terminal.
Yeah, we have a few modules to install, but yeah, if the Zoom link expire, we can go to the other link.
Okay. The problem with this.
Oh, what's this? You just don't send. But there is no, it's still running, I guess. It is probably because of the, when you install a library or a module for Pro, they will kind of, so what it does is trying to run some scripts to make sure that each of the functions works in your computer.
Always.
So actually in the background, it actually runs something, try to do some test. So that's why it take a very long time. Yeah, I think I did a small typo. So it, instead of install the software, the module I wanted to install, it also install others. So it takes a very long time. Or maybe it is the first time the PDL, because I'm installing the PDL Lite version.
Yeah.
So supposedly the LITE version, Lite version should be
Lighter.
smaller, like a smaller, but but it still takes a longer time than I expect.
What else do I need to install aside from this?
Huh?
What else do I need to install?
Yeah, so we have like 3 modules to install, and then after that we can we should be able to run the script I send you.
Okay.
Yeah. So how about like we can run this script now, and then you can see the table, and then at the meantime you can try the EB6. Maybe next week you can show me what you find in the EB6.
Sounds like an excellent plan.
Huh?
It sounds like a good plan. I hope to find something interesting.
Yeah. So you can try that one too. Maybe it may work, maybe may not work. I don't know. Yeah. So, but I think it's a good practice for you
Yeah.
to learn. Yeah.
If you want, you can send me the codes for the other packages that I need to install.
Yeah.
Run them when this is finished because the meeting will end quickly. I don't know if you want to start a new meeting.
Yeah. Let me see.
2 minutes left, it says.
Okay. I will send you the.
now it says CPAN 2 here. And
It's down?
I don't know, it got stuck on CPAN 2.
Oh, yeah. So this one, I think it looks okay. Let me see if the,
Yeah, send me another link because we have less than 1 minute.
yeah, okay. I'll send you another link.
Thank you. And I'm gonna leave this.